So far we've seen derivatives, and if we have y equals function of x, then the derivative dy over dx is simply f prime of x. And the key thing to note here is f of x is only a function of x, and x is the independent variable. When do we use implicit differentiation? The first case is y is a function of x and y. In other words, f of x comma y is a function of both the independent variable and the dependent variable. The second case is when we have a function of y equals to the function of x. So here we have a function of y and a function of x, where y is the dependent variable, x is the independent variable. So what is the key to differentiating? We treat y as if it is x. In other words, you treat the dependent variable as if it is the independent variable and multiply the term by the derivative of y with respect to x. As a simple example, if I have y is equal to e raised y plus x. So we have to find y prime, and if you observe the right hand side, that is both a function of x as well as y. So the first term, I'm going to treat the y just as x. So what is the derivative of e raised y? It's simply e raised y. But I multiply it by y prime, which is dy over dx, or y prime. And the derivative of x is simply 1. If I rearrange the terms, I have y prime minus e raised y prime equals 1. Y prime times 1 minus e raised y would equal 1. I'm pulling y prime out in common. So y prime is 1 over 1 minus e raised y. Why do we call it implicit differentiation? So y implicitly depends on y itself, and hence the name implicit differentiation. By all means, implicit differentiation is a generalization of differentiation. I just don't want to get into that. So the chances are, if we start with an implicit differentiation problem, the answer is likely to provide, or most often than not, likely to provide an implicit answer. So, which in this case, y prime is depending on y itself. And that is the key to implicit differentiation. So here we have to find the derivative. So that shouldn't be there. Of 2 root x plus root y equals 1. Now that is a function of x. That is a function of y. That is type 2, which is right here. We have a function of x and a function of y separately. So how do we find the derivative? So 2 times x raised 1/2 plus y raised 1/2 equals 1. The derivative of x raised 1/2 is 1/2 x raised 1/2 minus 1. We treat y as x, find its derivative, so we have 1/2 y raised 1/2 minus 1, but multiply it by the derivative of y, which is y prime. And the derivative on the other side, the derivative of 1 is 0. So the 2's would go away, and we'd have x raised negative 1/2 plus 1/2 y raised negative 1/2 times y prime equals 0. Which would mean 1/√x plus 1/2 root x, 2 root y, times y prime would equal 0. 1/2 root y multiplied by y prime is negative 1/√x. Multiply both sides by 2 times root y, we would have y prime equals negative 2 root y divided by root x. That simply is negative 2. Combine the roots together, we have y/x. As I mentioned in the beginning, if we start with an implicit function, more often than not, we will get an implicit derivative. That's exactly what happened. Y prime depends on y itself. So here is another example where we have a function of y and a function of x and y. So this is type 1 and type 2 combined together. So we have sine x plus y squared is equal to 0. Now we're going to treat that entire thing as one term. So the derivative of sine x plus y is cosine x plus y, chain rule, multiplied by the derivative of the inside. And derivative of x is simply 1. Derivative of y is y prime. And we have a function of y, which is y squared. We treat y squared as x squared. We know the derivative would simply be 2y, but we have to multiply it by y prime. And that would equal to 0. So distribute, we have cosine x plus y plus y prime cosine x plus y plus 2y y prime equals 0. Move the cosine x plus y to the other side. Y prime times cosine x plus y plus 2y equals cosine x plus y. Divide by that term on both sides. We would have cosine x plus y over cosine x plus y plus 2y. Again, the derivative depends on y itself. So the derivative implicitly depends on the dependent variable y. and hence the name implicit differentiation. You've got to keep in mind, can't stress this enough, more often than not, if we start with an implicit equation, the derivative is likely to be implicit also. So here the independent variable is t, not x. The dependent variable is y, and we have a function of y, we have a function of t and y, so both type 1, type 2 combined here. So how do we find the derivative? So first we have to use product rule. We'll call that u, we'll call that v. So u is e raised y, v is y squared plus t squared. U prime, well, e raised y is a function of y, the dependent variable. So we're going to treat y as x, but multiply it by y prime. So e raised y times y prime. V prime, y squared, is a function of y. We're going to treat it as x. So the derivative of y squared is 2y and multiply it by y prime. The derivative of t squared is simply 2t. Now if we use product rule, we have u v prime, so e raised y multiplied by 2y y prime plus 2t plus v u prime y squared plus t squared multiplied by e raised y y prime. And the right hand side, the derivative of y is simply 1. We have e raised y in common, so if we pull that out, we have 2y y prime plus 2t plus y squared t squared times y prime equals 1. Divide by e raised y on both sides, 2y y prime plus 2t plus y squared plus t squared y prime equals 1 over e raised y. 1 over e raised y is simply e raised negative y. Now, let's distribute and simplify. 2y y prime, 2t, plus y squared y prime, plus t squared y prime. Combine the terms with y prime in them. So we have y prime times 2y plus y squared plus t squared plus 2t equals e raised negative y. Move the 2t to the other side. It would become negative 2t, and divide by that term on both sides. We have y prime equals e raised negative y, negative 2t, divided by 2y plus y squared plus t squared. Again, y prime depends on y itself implicitly. So here we have a function, interesting one. We have to use chain rule and product rule. But before we do that, let's see if we can do an algebraic trick here. So the right hand side, I can write it as e raised yt times e raised 1 equals sine t. E raised 1 is a constant. So I'm going to divide by e on both sides. So 1 over e sine t. Now we have to find the derivative. So that right there is a function of both t and y. So that is of type 1 right there. So we are going to treat y as x, but multiply it by y prime. So the derivative of e raised yt is simply e raised yt, but we have to use chain rule, so we have to find the derivative of yt. On the right hand side, the derivative of sine t is simply cosine t. Now, e raised yt, we have to use product rule on the left hand side. So u is y, v is t, u prime is y prime, v prime is simply 1. So, in other words, du over dt would equal dy over dt. So the right hand side is e raised yt multiplied by uv prime y times 1 plus vu prime t times y prime equals 1 over e cosine t. Divide by y raised t on both sides, we have y plus t y prime equals 1 over e raised t times, 1 over e times cosine t divided by e raised yt. So y plus t y prime equals cosine t. Algebra, the bases are identical, so we add the powers. We have e raised yt plus 1. Now let's move the y to the other side. Ty prime would equal to cosine t over e raised yt plus 1 minus y, and divide by t on both sides. Y prime would equal to 1 over t cosine t divided by e raised yt plus 1 minus y. And in this problem, the independent variable is t, and the dependent variable is y.